All right, so now we're going to evaluate. Now, here, I want to figure out, what does this equal? What does this mean? If I plug in my calculator log base 4 of 64, what would I actually get out? So we're going to evaluate these. Now, one way to do this is, I don't know what this is. A lot of your calculators, you can't plug in a base that's a 4. You can only plug in a base that's a 10 or a base that's an E. So if I have log base 4 of 64, I might not be able to plug that in my calculator. So one way we can do this is set this equal to our unknown, and then we can use the swoop notation or the circle method, and where I say, hey, my base is 4, so 4 to the x power, so 4 to the x is going to equal 64. And so that's going from log form to exponential form. Well, now that I'm in exponential form, meaning I got rid of the log, I can try to figure out what x equals. Well, 4 to what power is 64? So basically I'm saying, okay, I have 4 to the x, and I need to know what 4 to the what power is 64. Well, when I think about it, okay, 4 times 4, so that's 2 times. 4 times 4 is 16. 16 times another 4 is 64. So that means 4 to the third power, or 4 times 4 times 4, 3 times, gets me 64. So see how these bases are the same? So 4 to what power is going to equal 4 to the third power? That means x has to equal 3. Meaning that when x is 3, or 4 to the third power is equal to 64. And so in this case, what we're saying is that log base 4 of 64 is equal to 3 because 4 to that third power is 64. So that means our unknown is going to be 3. It's kind of like when I say evaluate, even though we don't use a variable, if I said, hey, I have 1/2 of $10, evaluate that. Well, you know that half of 10 is $5. So in the same way, after we get used to logs, if I say evaluate log base 4 of 64, you could say, okay, well that's saying 4 to what power is 64? Oh, well 4 to the third. So that means that has to be 3. And with more practice, it gets a little bit easier. Now with number 2, we have log base 3 of this fraction, 1/9. So this is a little interesting. So let's try our method. And we're going to say, okay, well, let's get rid of the log by putting it in the exponential form. So I'm going to say 3 to what power is equal to 1/9. Well, over here, I was able to have 4 to the x, and I changed 64 to a base 4. How do I change this to a base 3? Let's ignore the fraction for a moment. And let's just put this in base 3, ignoring that fraction. 3 to what power is 9? Well, hopefully you know that 3 squared is 9. So I can say 3 squared. So, okay, so 1/3 squared. Well, these aren't the same. I can't just say, oh, x is 2, right? One's in the numerator, technically. One's in the denominator, so that doesn't really help me. If you remember with exponential properties, if you moved a term from the bottom of a fraction to the top, that exponent went from being positive to negative, or went from being negative to positive. The sign of that exponent changed. So if I move something out of the denominator and place it in the numerator, the sign of the exponent changed. And so in the same way, if I had something in the numerator and I moved it down to the denominator, the sign of the exponent changed. So in the same way, one thing I want you to know is that if I have 1/3 to the second power, that's the same thing as saying 3 to the negative second power. They mean the same thing. So now I have these two bases of 3 in the numerator, and so now I know that x has to equal -2. Meaning that if I were to evaluate this log base 3 of 1/9, it would equal -2. Meaning that 3 to that negative second power is going to equal, or be what equals, this 1/9. So again, practicing the swoop method or the circle method, and trying to manipulate these logs to see what they mean.